Question 831. 831. The question reads the following. This is page 224. The question reads the following. A Super Bowl mass M1 equals to 22 grams rolls with a speed of 3.5 meters per second toward another stationary Super Bowl mass of 27 grams. If the balls have a head-on, one-dimensional, elastic collision, what are the velocities, magnitude, and direction of the balls after the collision? So here we have an elastic collision problem between two Super Bowls. The first ball, we will draw the before and after collision diagrams here. So we have M1, M2, V1, while V2 was 0. M1 is 22 grams. V1 is 3.5 meters per second. M2 is 27 grams. V2 is 0. Elastic collision. So this is before the collision. This is after the collision. And by the way, here the direction for the V1 prime and V2 prime, I am assuming them to be in this direction. I don't know the direction. I'm assuming them to be in this direction. And I have to have also, once I do any conservation of momentum, I will be dealing with vectors. If I am to be, dealing with vectors, then I need to define my coordinates. Here I have a one-dimensional problem. X is enough. All of them are on the x-axis. So for me, I have to have the coordinates once I deal with the momentum. So let's start first with the definition of the elastic collision. An elastic collision means that the kinetic energy before the collision equals to the kinetic energy after the collision. And in this case, I will write EK before equals to EK after. Now let's look at the before. When I deal with the kinetic energy, I'm dealing with the scalar quantities. I don't look at the vectors. When I'm dealing with the kinetic energy, I'm dealing with the scalar quantity. So for me, in this case, I have to look at the kinetic energy for both balls, both masses, before and after. So in this case, this is going to be half M1 V1 squared plus half M2 V2 squared equals 2 half M1 V1 prime squared plus half M2 V2 prime squared. So my prime, the prime is for the after, the regular one is for the before the collision. Now I know V2 here is 0 because there was a stationary, then this means this whole kinetic energy would be 0. And I can also cancel the halves. So I will end up with m1 v1 squared equals to m1 v1 prime squared plus m2 v2 prime squared. Now if I am to substitute, I have m1 as 0.022 times, so said here v1 is 3.5 squared equals to 0.022 times v1 prime squared plus 0.027 v2 prime squared. Now I need to keep my equation simple. In this case, let me get rid of the 0.022 by dividing the whole equation by 0.022. And in this case, so dividing by 0.022 gives me the following. So here I have the 3.35 as 12.25 equals to v1 prime squared plus 1.23 v2 prime squared. So this is basically how I can write it. v1 prime squared plus 1.23 v2 prime squared equals to 12.25. Let me call this one equation 1. So this equation I developed it from the conservation of kinetic energy, knowing that the collision is elastic. Now let's move to the conservation of momentum, where I have sigma p before equals to sigma p after. Let's look at our vectors here. I have v1 in the x direction positive, v1 prime assumed to be in the x direction positive, v2 prime also assumed to be in the x direction positive. So I can write now my momentum equation for the before as m1 v1 plus m2 v2, this is 0, equals to m1 v1 prime plus m2 v2 prime. Right? Now I can get rid of m1 to make my equation look simple, dividing by m1. Then I have v1 equals to v1 prime plus m2 over m1 v2 prime. Or I know v1 is 3.5 equals to V1 prime plus, I know M2 as 0.027 or 27. Here it's the ratio, doesn't matter. V2 prime, or rearranging this equation, I will be getting V1 prime plus 1.23 V2 prime equals to 3.5. So this equation number 2. Also, I can now write V1 prime in terms of V2 prime, which will get to 3.5 minus 1.23 V2 prime. So this one 3. Now substitute 3 and 1. If I substitute 3 and 1, then what do I get? I get 3.5 minus 1.23 V2 prime squared plus 1.23 V2 prime squared equals to 12.25. Alright. Now this one would be this one squared, which is 12.25 minus 2 times the 3.5 times 1.23 is minus 8.61 V2 prime plus 1.513 V2 prime squared plus 1.23 V2 prime squared equals to 12.25. 12.25, 12.25 will cancel. Rearranging the equation, then my equation would look like 2.74 V2 prime squared minus 8.61 V2 prime equals to 0. Take the V2 prime outside. V2 prime 2.74 V2 prime minus 8.61 equals to 0, which is V2 prime equals to 0, which is a trivial solution. The second solution is 2.74 V2 prime equals to 8.61, and in this case V2 prime equals to 8.61 divided by 2.74 V2 prime as 2.14 meter per second. Now I'm going to call this equation 4, and then 4 and 3 will give you V1 prime. So this now will be V1 prime equals to 3.5 minus 1.23 times 3.14, and the answer is V1 prime equals to minus 0.36 meter per second. Now, notice that I assumed v1 prime and v2 prime to be in the positive direction. However, the calculation now told me that v2 prime indeed is in the positive direction. However, v1 prime is in the negative direction. The next question is question 858. 858. The question reads the following, page 231. 858. Imagine that you are standing still and someone is about to run into you. Making a completely inelastic collision. So our collision here is completely inelastic. In which situation would your speed after the collision be greater? If the runner has a large mass and a small speed, or if the runner has a small mass and a large speed. However, the momentum here is about the same magnitude of momentum. So this runner has the same momentum in both cases. Momentum is his mass times his velocity. So he has the same momentum for both cases. We want to see which case the u will be having a greater velocity. Is it when he has a small mass, large speed velocity, or large mass, small velocity? So let's start first by writing down or drawing uh, the diagram before and after. So this is before. This is mass. This is the runner. That's you. You were stationary, which means that your velocity was 0. He was running toward you with velocity v1. After the collision, both of you became one mass. I have here m1 plus m2, and both of you will have the same velocity. Here I'm saying v prime equals to v1 prime equals to v2 prime because both will have the same velocity after the collision. Now let's put the conservation of momentum equation. I have sigma p before equals to sigma p after. My coordinates are the following: x, y. However, this is a one-dimensional problem. So all of them, this is 0. The prime is also assumed to go in the positive direction of x. So here I have m1 v1 plus m2 v2 equals to m1 plus m2 v prime. This is 0, which means that m1 v1 equals to m1 plus m2 v prime. I'm interested to evaluate v prime. So v prime is m1 v1 divided by m1 plus m2. Now this is constant. So we have here p1 as constant divided by m1, m2. Now, if m1 is smaller than m2, then v1, v prime will be large, right? If m1 is small, then v prime would be large. However, so if m1, the runner, is smaller than u, is less than u, then v prime will be large. If m1 is greater than m2, then v prime will be small. So in summary, if you have the mass being small and the velocity being high, then this is going to result into a faster velocity for you if you got hit in this scenario. If he has bigger mass, low velocity, same momentum in both cases, then your velocity is going to be small, which is this scenario. Low mass, high velocity, his velocity is high, then this is going to result into a large velocity. Big mass, little velocity, it's going to result into a small velocity after the collision. Any question about this problem? Okay, so let's move on to the next question. 859. In 859, we have two pucks on an air hockey table are equipped with spring bumpers and make an elastic head-on collision, which means that we have here one-dimensional problem. One puck mass 253 grams and has an initial speed of 1.8. The other puck has a mass of 232 grams and is initially stationary, so V2 is 0. What is the velocity, magnitude, and direction of each puck after the collision? So we have here one of them stationary, before, after, M1, M2. So this is an elastic collision. Again, the direction of the after, it's up to you. You're gonna take them both in this direction. You're gonna flip one. It's up to you. For simplicity, since my coordinates is x in this direction, I took them in this direction. V1 prime, V2 prime. So in this case, this problem is similar to the one we did at the beginning. We have here EK before equals to EK after. I have half M1 V1 squared plus half M2 V2 squared equals to half M1 V1 prime squared plus half M2 V2 prime squared. Now this one is 0. I can cancel now the halves, and then rewriting this equation, I will do it now in a different way. I will divide by M1, so I have V1 squared. This is 0 equals to V1 prime squared plus M2 over M1 V2 prime squared. So I have V1 prime squared plus M2 over M1 V2 prime squared equals to V1 squared. Now substituting, I have V1 prime squared plus M2 over M1, which is 0.222 divided by 0.253 V2 prime squared equals to 1.8 squared, which is 3.25. And this is V1 prime squared plus 0.917 V2 prime squared equals to 3.25. This is my first equation. See how I got rid of the M1, made my equation simpler. Now the second equation is the conservation of momentum. So I have B before equals sigma B after. So what do I have here? Remember, I assumed the V's primes to be in the positive direction, so I can right away write all of the V's will be in the positive. So I have here M1 V1 plus M2 V2 equals to M1 V1 prime plus M2 V2 prime. I have this is 0. Then dividing by M1, which is V1 equals to V1 prime plus M2 over M1 V2 prime. I know V1 is 1.8. Then V1 prime plus the same ratio here, 0.917 V2 prime equals to 1.8. This is my first equation. This is my second equation. From 2, I have v1 prime equals to 1.8 minus 0.917 v2 prime. Now substituting this one, if I am to call this one 3 and 1, what do I get? 1.8 minus 0.917 v2 prime. The whole thing is squared plus 0.917 v2 prime squared equals to 3.25. Now here the same thing here is going to happen. I have 1.8 squared minus 2 times 1.8 times 0.917 v2 prime plus 0.917 squared as 0.841 v2 prime squared plus 0.917 v2 squared prime equals to 3.25. Now this one is going to give me 3.25 here as minus 3.3 v2 prime plus, if you add those two, what do you get? Now hold on a second. 2 times 1.8 times 0.917. Yeah, so 3.3 v2 prime 0.841 plus 0.917 is plus 1.76 v2 prime squared equals to 3.25. Now 3.25 and 3.25 will cancel, and we are going to end up with 1.76 v2 prime squared minus 3.3 v2 prime equal to 0. Take the v2 prime outside. 1.76 v2 prime minus 3.3 equal to 0. So the solution is either v2 equal to 0, which is the solution, or 1.76 v2 prime minus 3.3 equal to 0. And in this case, v2 prime as 3.3 divided by 1.76 v2 prime equals to 1.875 meters per second. Call this one 4. Then substitute 4 and 3. And you have here v1 prime equals to 1.8 minus 917 times 1.875 beyond foreign as 0.0806 meter per second. Question 863 reads the following. Two trucks have a completely inelastic collision. After the collision, they have a velocity of 11 meter per second at 35 degrees south of west. So let me first start with my coordinates x, y. This is a 2D, this is a two-dimensional, uh, completely inelastic problem. So in this case, x will be pointing toward the east. This is west, and this is south. I have the two trucks after the collision being one mass, m1 plus m2, with a velocity 11 meter per second at 35 degrees south of west, which is, if this is west, then the velocity will look like this. This is v prime. So I will put here v prime as 11 meter per second, and this angle as 35 degrees. Before the collision, one truck that has a mass of 2.3, so I have m1 as 2.3 10 to the power 4 kilograms, and a velocity v1 15 meter per second at 51 degrees south of west. So let's assume that my m1 is here, and now south of west 51, something like this. And the angle here is 51 degrees. And then mass number 2, what do I know about it? I know the mass, 1.2 10 to the power 4 kilograms. I don't know the velocity, which means I don't know the velocity magnitude and the angle. So I would assume it to be this. This one is going to be V2. So let me draw this one blue, just to make it thick. I need to determine the initial velocity, magnitude, and direction of the other track M2 that has a mass of 1.2 10 to the power 4 kilograms. So how do we solve this problem? This problem is a two-dimensional, completely inelastic problem, which means I will have to use the conservation of momentum on the x and y components, because as you can see here, we're dealing, when we talk momentum, we're dealing with vectors. When we say vectors, and they have, as you can see, uh, directions, angles like this means I will be dealing with the components on the x and on the y. So let me start first by finding those components on the x and on the y just to make my life easy. So I will start with the, so before I do this, let me just say that this is the after, and this is the before. So my x is the projection. So I have this component. I will do the x components with the blue. So this is my x component, and this one is v prime cosine 35 degrees x component, and this one is v1. This is v1, and this is v1 cosine 51, and then I have this one, and this one is v2 cosine theta. Now let me do the y components in green. Then the projection of the for the y component, it will be projected this way. So this is my y component here, which is v prime sine 35 degrees. Same here. This one is v1 sine 51 degrees, and this one is v2 sine theta. I need to do the conservation of momentum, but now I do it for the x and the y. So I have before sigma bx after, and also sigma py before equals to sigma py after. Let's start with the x's. As you can see here, all the x components are pointing in the positive direction. So make sure that when you write this equation, you take care of the sign as well. So I have here minus m1 v1 cosine 51. I'm in the before, minus m2 v2 cosine theta equals to minus m1 plus m2 v prime cosine 35, right? So I have minus m1 v1 cosine 51, which is this one, minus m2 V2 cosine theta equals to minus M1 plus M2 V prime cosine 35. Yeah. So this is the first equation. Rearranging this equation, minus M1 is 2.3 10 to the power 4. V1 is 15 times cosine 51 minus M2, which is 1.2 10 to the power 4 times V2 cosine theta. I don't know those. Minus M1 plus M2 is a 3.5 10 to the power 4 times V prime, which is 11 times cosine 35 degrees. Now 10 to the power 4 can cancel, it's the same in all of them. And then we have cosine 51 times 15 times 2.3 as minus 21.71 minus 1.2 V2 cosine theta equals to, I have cosine 35 times 11 times 3.5 equals to minus 31.54. Now, if I bring this one to this side and this one to that side, what do I get? I get 1.2 V2 cosine theta equals to 31 minus 21.71 is 9.83. Then V2 cosine theta is 9.83 divided by 1.2, or cosine V2 cosine theta equals to 8.1 now. I call this one 1. Then the second equation comes from the conservation of momentum for the y component. So that one let's see what we have here. We have the same thing, however, we have to be careful for the angle. Now we were dealing with sine. And also, 3 of them are negative. They're pointing in the negative direction. So if I am to write that, it will be not that different except for the sign here. Minus M1 V1 sine 51 minus M2 V2 sine theta equals to minus M1 plus M2 V prime sine 35 degrees. Again, substituting here, minus 2.3 10 to the power of 4 times V1, which is 15 sine 51 minus 1.2 10 to the power of 4 times V2 sine theta equals to minus 3.5 10 to the power of 4 V Prime is 11 meters per second times sine 35 degrees. Again, 10 to the power 4 cancels. Then we have sine 51 times 15 times 2.3 is minus 26.81 minus 1.2 v2 sine theta equals 2 minus 22.008. Again, take this one to the side and this one to that side. We have 1.2 v2 sine theta equals 2. I have minus 26.81 plus 22.08 as minus 4.73 and v2 sine theta as minus 4.73 divided by 1.2. v2 sine theta equals 2 minus 3.94. Okay. So this is question number 2. Now, if I divide number 2 by number 1, what do I get? 2 divided by 1, then I get v2 sine theta divided by v2 plus sine theta equals 2 minus 3.942 divided by 8.19. And the answer is minus 0.481, or theta equals 2 tan inverse minus 0.481, and theta equals 2 minus 25.7 degrees. Now, if you want to calculate V2, then this is 3, then 3 and 2, V2 sine minus 25.7 degrees equals to minus 3.942, then V2 equals to 9.1 meters per second. Now it's very important to know what does minus 25.7 here. If you go back to the diagram we drew, you can see that We assume that theta positive going this way from the west to the south, which means the positive, now I have negative, then it will be going the other way. So indeed, the answer or the solution for theta being negative is going up this way, and it's 25.7. Then let me make this one a bit smaller to represent 20 something. So this is the angle that I found, and this is the magnitude of 9. So I assumed it to be this one in this direction with this angle. This was an assumption. After I did the calculation, I found out that the angle indeed is above, is west toward the north, not west toward the south. Let's do part B here. Part B is what percentage of the initial kinetic energy is lost in the collision. So when it comes to the kinetic energy, again, we treat it as a scalar. So we said that the momentum is use the velocity, right? However, the energy here is a scalar. So in this case, I need to write the kinetic energy before the collision and the kinetic energy after the collision, and then find the lost energy. So in this case, I will write EK before, and this equals to half M1 V1 squared plus half M2 V2 squared. And in this case, let me call this one EKB. Half the mass M1 is 2.3 10 to the power 4. The velocity here V1 was 15 meter per second plus half M2 was 1.2 10 to the power 4, and the velocity is what we found right now, which is 9.1 squared. EKB in this case going to have 15 squared times 2.34 divided by 2. This is 2.587 10 to the power 6 plus 4.9686 power 5. Then EKB is 3.084 10 to the power 6 joules. This is the total kinetic energy before the collision. Kinetic energy after the collision, EKA, is, now remember here we have completely inelastic. So we're talking here about a one mass that sums both of them. So half M1 plus M2 times V prime squared. So here EKA is half times 3.5 10 to the power 4 times 11 squared. Why? Because the prime is 11 meter per second. So EK is 2.12 10 to the power 6 joules. Now the percentage here of the lost is 3.084 10 to the power 6 minus 2.12 10 to the power 6 divided by the original 31%. Is 0.31 and percentage EK loss and it is 31%.